Hello everyone, my name's Adam in Positive. Welcome to my next video. And I've been thinking for a little while that I've wanted to make a plugin for managing and for browsing through drum and percussion samples. Well, the problem that I was trying to solve at first was, you're flicking through your drum and percussion samples, and every sample library is all recorded at different levels. Some of them are producers want the really loud samples, because they want to sell lots of samples. And then they've got the other sample packs where everything's released at mixed level. You just load it in, it's beautiful. But then when you're flicking between those, you're constantly readjusting. You're going, you've got loud samples, you've got quiet samples. Oh, what am I going to do? Anyway, so that was the first problem that my plugin was to fix. Then a few weeks ago, I had an idea while I was playing around with the compressor on a kick sample. I was trying to increase the transient level, but I had this annoying click sound at the beginning. Now, I liked the sound of the kick, but I just didn't want this click sound. Now, there's so many ways that you can try and remove it. Like you could try and EQ to kick out the click, or you could try and put a fade in at the beginning of the sample. But I was just having a lot of drama with it, and I was thinking there's got to be an easier way. And I was thinking about the compressor and the envelope detector, and then I had an idea. So I whipped up something really quick in Juice. The result was really good. So I just got to work on it and started putting this plugin together, and that's what this video is going to be about. It's going to be about this plugin and the work that I've been doing over the last few weeks, and this new algorithm, this new envelope detection algorithm that I've come up with. So this is the plugin. Got two parts to it. There's the envelope detection, and there's one version of the processing algorithm. And there's the other aspect of this plugin is that I've created a database of all of the percussion samples that I've got: kicks, snares, claps, cymbals, hats, toms, everything. And I've created a list here of everything that I can search or filter by the different categories that I've got. So let's load a kick drum. I'm going to go to the Computer Music Magazine collection of acoustic kicks. If I type computer. So all of my Computer Music Magazine samples are now in there. Loads the sample here, and it trims the sample to a length 33% of a quarter note, or I can have that in milliseconds. But basically, all of the samples now, when I load them, they'll be trimmed to the length that I want. The default parameters that I've got here are the settings that I would typically use for a kick drum. And then you've got this playback KRMS parameter. So this sample is only trimmed and faded at the end, and it's normalized to playback at minus 15 KRMS. Got to bring the fader down as well. So now I've got a kick that I can put a pattern down for. Let's load another playback engine. This one we will find a snare. Sounds good. Once again, normalized to the same level. So if I play that, make a rough balance. Might bring that snare down a little bit. The plugin will automatically normalize these samples, and it's not by RMS, it's by KRMS. The K-weighted RMS measurement is the same measurement that's used in your LUFS meters. It's not LUFS though, because LUFS will process everything in 100 millisecond blocks and take an average of those and do all sorts of other stuff. No, this is KRMS. An important thing about it is that it will only measure the first 100 milliseconds of the sample. And that way, essentially normalized so that the transient levels are the same throughout. Cool. Now, oh, that's a rim sound. Might put an actual snare sound. Let's find a different kick sound. Now, see here, really loud, distorted kick, but it's reduced the level of it so that it plays at the same KRMS level. So going through, I can pick the sounds I want and I'm not having to rebalance. Okay. I've picked the samples that I like, and now I can do some dynamics processing. I've got here a demo, and I can drag a sample into it. The demo doesn't make any noise. It's purely a visual demo. So to compute this envelope, there's 4 main steps. So if we can zoom into the waveform, and I can show you the first stage. We're just turning this refine parameter down to 1. So this is the first stage of the envelope finding algorithm. And what it does is it goes through and it looks for all the 0 crossings in a waveform. And then in between each 0 crossing, it finds the maximum amplitude of the waveform and it puts in a maximum point. It puts in a point in the envelope. So in between these points, the envelope's linear, and at these points, the envelope has a abrupt change. Now, as you can see, there are parts like this sneaky part here, the 0 crossings down here somewhere and over here somewhere, and there's the maximum point, and we've got this little point that sticks out over the top. But you can see as well, you got this pair here, this guy's, because there's the 0 crossings there, and there's the maximum, and then there's other points there. So you've got this pinch, which I don't think is very desirable. But it's given us a pretty fair waveform to go with, you know, especially down here at the low parts where all of the high frequencies have pretty much disappeared and the 0 crossings are very much spaced apart. The envelope has gradually tapered off and has created a nice shape. And this is the kind of shape that I want to have the whole way through here. So that's the second stage of the algorithm, is where we do what's called clumping. Well, what I've called clumping. So if I go to stage 2, simply computes the wavelength of this threshold, of this frequency. For a 200 hertz clumping frequency, the wavelength is 5 milliseconds. What the algorithm does is it goes through, and for every point on the envelope, if there's any other point within 5 milliseconds, which is lower than that, it will delete it. And that gives us this much nicer, already much better looking wave envelope. We still have some points, especially in the attack phase, where we have points that are sticking out, and we may have others further along. And we still have little pinches like this, but I think that this is acceptable. You know, I'm happy to use that. We can change this clumping frequency, and you'll see that it will introduce a bit more detail, but it'll also, as inevitably, introduce a lot more of these pinch points as well. So that's why this frequency is available for me to tweak with, because I find that it's handy to find a nice threshold. A note here too, I'm using frequency instead of distance. I find that it's a lot more intuitive to understand what the resulting sound might be. So that's stage 2. Stage 3 is where the remove threshold is processed. So if we put those pinch points in, we can remove those lower pinched samples, and we can have a lot more detail in the envelope. And now the envelope is roughly following the main shape, you know, of this kick sample. Then the next few stages, it's the same stage run over and over again. And this is to catch those points, like this one here at the beginning, which have poked out above that envelope. It simply goes through, and for each segment, so for each segment, it will find the point which is deviated the furthest, and it will add an envelope point for that. And the option is there to iterate a few times over this part of the algorithm to catch more and more as we go. And I've found that the vast majority of examples that I've put through this, it will find and it will fit an envelope after 5 or 6 steps. And the result then is pretty good. 1,000's too high for this, so I bring it down to, for kick drums, I found 200 works pretty well. Before I can do the dynamics processing now, I need to do the envelope detection, and that's what this freeze button is for. So when I click freeze, and there's my envelope, there's my clumping frequency and remove threshold parameters, and this box contains the envelope that I want to impart onto that sample. And the default is a full amplitude all the way. I can draw in another parameter there, and there you can see I can manipulate the envelope. And this envelope and this waveform is the same length, but see now the length is frozen, but I can still adjust the playback level. And this is really important because what it means is that as I adjust the envelope, it'll recalculate the playback level and renormalize the sample. So let's change this reshape amount parameter so that we can impart this full envelope, full amplitude across the whole thing onto, and you can see that the sample changes and it shows you what this envelope now looks like. We can hear it. Now this is being reprocessed. It reprocesses the entire sample every time you change a parameter. That's why you get that sort of staticky, distorted sort of sound while you're moving the parameters. But when the parameters are left untouched, you get the sound as it is coming out of the algorithm. So that's with nothing, and that's at full processing. Now, of course, this is a rubbish sounding snare. But drawing that envelope back in, I've created this nice, it's a linear taper. We can change that to an exponential one, hold it down the shift key. And now I've taken this envelope shape and changed it so that it's now this slow taper instead of this sort of lump. Yeah, and I can turn it off and on and hear the difference. It's a bit fuller, or it's a lot fuller, and it might be better sounding to your taste. Let's add a little click at the front. And you see as I'm doing it, it's normalizing that level so that I don't have to rebalance it every time. But it's changing the envelope, the sound that we want. Pretty cool, eh? Let's freeze the kick and do the same thing. You see it's created this big node But you've got this little attack at the beginning here, which is pretty quiet in this kick. Let's draw out the envelope first. There you go, see that? Or I can just reduce it a little bit. And let's look at what else we can do with this. We can increase this clumping parameter. We can capture a lot more of that information in the envelope, and you can see down the bottom how the result, there's that little click, the tail of the click that gets captured and gets increased. It only works up to a certain point. You get that diminishing returns. But the lower frequency gives you back a little bit of that boom. But the default for 200 should work there just fine. There we have it. And we can hear what they sounded like originally. Hear the processed versions. Yeah, immediately you can hear the difference. And I have no other processing on those signal chains. It is simply that. You know, next I might put an EQ just to round off the low end, especially on that snare. Sit endlessly playing with this, and the tonal changes that you can produce by shaping the envelope. You know, I'm really surprised myself just how much change you can make to the tone by just adjusting the envelope. It's pretty incredible. Now I can bring out the higher frequencies, bringing the envelope a bit closer to the front. Or I can bring out the boominess. Although this sample doesn't have that much boom in it. It's got a nice sound. This has a nice little attack at the front. Might even sound good. Now, in your opinion, do you think I need to rebalance it? Because everything's being rebalanced on the fly. Once you've got that balance set at the front, at the start, there's no need to worry about it. Personally, I don't think I need to rebalance that. Yeah, I can, make real objective decisions about whether I like the sound of it or not. And I'm not going to be tricked by the perceived change in loudness, because there is none. The loudness is staying the same with each element. The balance is staying the same. Let's change the kick pattern so that we've got something a bit more 4 on the floor. Now, this is still in development. There's like a lot of things that are missing from this. For example, the ability to just quickly reset the envelope. Or to, for example, copy this envelope down here. That's going to be the next stages of this development. Kick sounds. Let's go into my Vengeance Club Sounds collection. Clubby sort of kick. Let's get a clap. Let's get one from, I've got the Smoker's Relight collection there. This sample collection is a really good example as well of like normalization. Even within the same sample pack, look at the differences in level. Some of them are a lot quieter than others. And it's like, I'm trying to pick a sample, guys. I don't look at that, how much quieter that is. But this will automatically, if you look down the bottom here, it's automatically reprocessing the loudness so that I don't have to worry about rebalancing this mix again. I can change the tempo. Let's make it 130. Just change the lengths. because I don't have a bass line, yeah, I can get away with a 50% of the quarter beat. Look how much easier that just became. Oh, I don't like that. I don't like that clap. Let's go to that really quiet one. Where was it? There it is. Very good. Actually, no. I want to add a little bit of I want to increase the tap a little bit on this kick. And I went from a indie sounding sort of kick, snare sort of combo to a 4 on the floor club sound without rebalancing. Well, I mean, in my opinion. Let us know in the comments what you think. Do you think I need to rebalance this as I'm going along? Or do you think that my balance at the beginning here is not that great? Maybe I need to make the snare a bit lower or whatever. Hit me up. Tell me. Tell me if you think you'll use something like this. I've been having so much fun with this. I haven't even finished developing it. I haven't put in half of the features that I want to put in. For example, filtering. I'd like to be able to filter and then normalize, right? Might mute this kick and get rid of that. And we'll see here we've got this snare, which has got the way this envelope is shaped, like I was talking about this before. We can capture these details in between here with a higher clumping frequency. Sounds more snare-like now, doesn't it? If we look at the waveform down here, all of these individual parts have now been flattened out. I could go through the work of adding them back in. There we are, it looks like a clap again. Hooray, it crashed. Wonderful. Let's see if it crashes when I restore the live set. It does. All right then. Well, that very quickly put an end to that. Yeah, still in development. So I may or may not have, by the time I put this video up, have a GitHub repo with the code. I'm still using Juice 7. I started this a couple of weeks back before Juice 8 was released, and now they've released Juice 8, and they've got that starters developers license that you can get for free, and that's this new feature of Juice 8 with the web-based plugin interfaces. Looks really interesting. Imagine being able to reconfigure the GUI, reskin it, or whatever without recompiling it. That's just going to be amazing. So I'm definitely thinking about perhaps refactoring this or recoding it using Juice 8 before I upload it. But I do need to get some content out there, so the video might beat the GitHub repo. So if you've watched this video and there's no GitHub link, just come back and check on it, or I might post another video later. So I'm going to leave it there. I've got to get some content out. So if you've enjoyed watching this video, watching me drag on, reach down there, hit that like button, hit the subscribe button, leave me a comment. Don't care how bad or good it is, but it really helps me. I really appreciate it. If you're keen on getting involved, doing some testing, hit me up. Leave a comment down there, and I'm all ears. Hopefully, I'll have a GitHub repo up soon once I've cleaned up the code, and yeah, I'll see you guys in the next video.